Hi, Chris Good here, and this is another video where we're going to look at a t-test that we assigned in class this week. This is number 2, so if you were in the group that got number 2, this is the experiment where they wanted to examine the effect of perceived control on health complaints of geriatric patients in a long-term care facility. 30 patients randomly selected. Half are given a plant to care for and half are given a plant, but the care is conducted by the staff. That's a really neat control. So really what they're manipulating is whether they are in control of the care of the plant. And they have, I guess, some reason to suspect that caring for some living thing might have some kind of effect on health complaints. So that's what we're measuring. Health complaints are recorded over 7 days. Compute the appropriate t-test for the data provided below. Well, if we're going to do this by the book, we need to state our null hypothesis. Now, it looks like a true experimental design, and it says that half are given a plant to care for. It looks like the other half are given the plant, but the staff is doing the care. I'm going to assume that we've randomly assigned people to do this or the other thing. That's pretty clear that half are doing one, half are doing an other. N equals 15 in each group, so let's make a note of that. N1 equals 15, N2 equals 15. We can actually go ahead and calculate our degrees of freedom. That's N1 minus 1 plus N2 minus 1. Or 15 minus 1 plus 15 minus 1. Oops. Let's put our parentheses in correctly. That's 14 and 14, which is 28. Those are degrees of freedom. It's important that we, and those are the degrees of freedom for the independent measures t-test. And these are independent groups. These are different people. Control over the plant, different people than no control over the plant. So, the null hypothesis for that independent measures t-test is that there's no difference between the population means or that there's a zero difference. Step number 2 is to set alpha. For all these, we're going to use 0.05, as usual. Don't have any reason to go higher or lower than that. And the critical value for t, for 28 degrees of freedom, we'll have to look up on our t-table, which I have right here. Alright, so we're looking for 28 degrees of freedom, and this is the column for 0.05, right? So 28 degrees of freedom, 2.048. 28 degrees of freedom, 2.048 is our critical value. So we know that that's a two-tailed test plus or minus 2.048. Okay? Step number 3 is to calculate your statistic. The independent measures t-test is the difference between your two means minus the hypothetical difference between your population mean divided by the estimated standard error of the difference between the two means. That estimated standard error, right, requires the pooled variance in the independent measures t-test. So to get the pooled variance, we need the sums of squares and the degrees of freedom for each group. The sums of squares then is the tricky part here because we have so many very big numbers. But it's always the sum of the scores in your distribution minus the square of the sum of scores. Sorry, it's the sum of the squared scores minus the square of the sum of scores divided by the number of scores. Okay. I'm going to put the squares out to the left of this distribution, so let's just get our squares really quickly. That's 529, 144, 36. Some of these I know already. 225, 18 squared is 324, 25, 21 squared is 441, 18 squared again, 324, 34 squared, 1156, 100, 23 squared was 529. Already did these before, some of them. 196 for 14. 19 squared is 361, and 23 squared, 529 again. 529, I'm going to go up from the bottom, plus 361, plus 196, plus 529, plus 100, plus 1156, 324, 441, 25, 324, 225, 36, 144, and 529. I get 4919, and I'm going to put that over here as well. 4919. Now I'm going to add up all the individual scores. 23 and 12, and 6 and 15, and 18, and 5, 21, 18, 34, 10, 23, 14, 19, and 23, and 8. Oh, I didn't do 8 there. I need to add that. That's 64. I'm going to add that in over here as well. If you find a mistake, just go back and fix it. The total of the scores then is 249. We're going to square that over here. I've got to add that back in here. 64 plus 4919 is 4983. That sounds more like it. There's 15 total scores. So 249 squared is 62,001. 4983. 62001. 249 squared. Yeah, that's right. Over 15. That's 4983 minus 4133.4, or 849.6. All right. Let's do sum of squares for group number 2. Again, I'm going to put the squares to the left of the numbers here. Okay, 35 squared, 1225. 21 squared, 441. 26 squared, 676. 24 squared is 576. 17 squared is 289. 23 squared is 529. 37 squared, 1369. 22 squared is 484. 16 squared is 256. 38 squared is 1444. 23 squared is 529. 41 squared, 1681. 27 squared is 729. 24 squared, 576. Let's not forget this last one this time. It's 32 squared, or 1024. I'm going to add them all up, going upwards. 1024 plus 576 plus 729 plus 1681 plus 529 plus 1444 plus 256 plus 484 plus 1369 plus 529 plus 289 plus 576 plus 676 plus 441 plus 1225 is 11828. So 11828 here. I want to get sum of x next, so from the top down, 35 plus 21 plus 26 plus 24 plus 17 plus 23 plus 37 plus 22 plus 16 plus 38 plus 23 plus 41 plus 27 plus 24 and plus 32. 406. We're going to square that, divided by 15. 406 squared is, 11828 minus 16, 164, 8, 0.36 over 15 is 10989.07 with rounding. 11828 minus 10989.07 with rounding. You're going to get something close to 838.93. Or 94, something close to that, depending on how you do your rounding. So I'm going to add these up, 838.93. Add up the 2 degrees of freedom, that's 14 plus 14. And I end up with 1688853 over 28. Sorry, that's 1688.53 divided by 28 is 60.3 with rounding. Okay, that's our pooled variance. We can plug this in, 60.3, and chug along. 60.3 divided by 15 plus 60.3 divided by 15. I get the square root of 4.02 plus 4.02, or the square root of 8.04, which is 2.84. Great. Now we can go up here. I haven't computed the means yet. There's a space for it here on the paper. I know that the sum of x for this is 249. Divide that by 15 and we'll get our mean. The sum of x for this one is 406. Divide that by 15 to get that mean. Let's look at our means. Divided by 15. 16.6 here. 27.07-ish over here. I'm going to go ahead and subtract them as we see it, control minus no control. 16.6 minus 27, sorry, 0.07 over our estimated standard error, 2.84. That's negative 10.47 over 2.84, or negative 3.69. It looks like it's going to be in the critical region, right? Let's shade this in here. You know, the center of the distribution is 0. This will be plus 2.048, minus 2.048. 3.69 is negative 3.69, sorry, is in this tail. But it is in the tail, and it is in the shaded region. So step 4 is to reject the null. Let's see what that means. Go back to the test. Half are given a plant to care for, half are given a plant, but the care is conducted by the staff. The number of health complaints are recorded, right? This is the mean for the people who had control. This is the mean for the people who had no control. If you were thinking the people with no control did better, keep in mind that these are the number of health complaints that they're making. Bigger number is worse. This group made fewer health complaints. So we can conclude, since we rejected the null, that the patients given control over the care of a plant made significantly fewer, not less, fewer complaints. Complaints are discrete. Health complaints. Than those whose plant was cared for by staff. I can go ahead and put in my statistic here. I'm running out of room, but I really want to fit it in APA style. T with 28 degrees of freedom is equal to negative 3.69, comma, I'm almost done with the sentence. I'm still in the sentence, see? 3.69. P, we don't know anything about P other than it's less than what our alpha was. If we were using a computer program, it would give us what P is equal to. All we can say is P is less than 0.05. All right, so it looks like plants are good. This was a true experiment with random assignment. There's no evidence here of confounding, so I think we have to conclude that, yeah, it was the caring for the plant that caused them to have fewer health complaints. It wasn't the plant. These guys had a plant too. It was just that somebody else was taking care of it. All right, that's it.